Okay, today we're going to be talking about similarity and similar figures. Before we do, let's review what a congruent figure is. Congruent figures are figures that are the same shape and they're the same size. So it's basically the exact same shape, it's just in a different spot on your page or in the plane. Similar figures have the same shape, but they're different sizes. So that might look like two triangles that look exactly the same. One's just like a shrunken down version of the other. Or two squares that are essentially the same, but one's a little bit bigger than the other. So when we get into similar figures, we've got to look at the angles and the sides. If two polygons are similar, the measure of their corresponding angles are congruent. So every angle is going to have like a pair in the opposite figure that's congruent with it. And the lengths of the corresponding sides are proportional. So what that means is that if one side length is 2, the other one might be twice as big, so it'd be 4. If one side's 8, the other side would be 16, so it's twice as big. Let's go ahead and look at what it looks like to find congruent angles and proportional sides. What we're going to do on this page is we're going to prove if shapes are similar. And what we're going to do is we're going to look at every angle of the shapes and then every side length of the shapes and then decide if the two shapes are similar. If they are similar, we'll learn how to write a similarity statement and we'll learn what a scale factor is. So the first thing we're going to look at is we're going to look at these two triangles here and we're going to list our congruent angles. So notice that angle R and angle Y are both 112 degrees. So we could say angle R is congruent to angle Y. Also notice that angle Q and angle X are both 24 degrees. And then we've got to figure out what angle Z is. Hopefully it's 44, so it matches up with angle P over here. To figure out this third angle, we can just subtract from 180. So 180 minus 112 minus the 24, and we'll get 44 degrees, which means that angle P is congruent to angle Z. So these two triangles, all the corresponding angles are congruent. Now we're going to write what's called a statement of proportionality. A statement of proportionality is when we're going to look at the fractions of each of the side lengths. So we're going to pair up corresponding sides. So for example, the 9 matches up with the 6. Okay. This side 12 matches up with 8. And then we have the 18 over 12. Okay. When you're writing your statement of proportionality, there's a couple things you need to be careful of. First of all, you have to make sure that you put all the same fraction lengths on the same side of the fraction. So like all three of those numbers that are on top of the fraction are from my first triangle. So you've got to make sure that all the numerators are from the same the same triangle. And then you also want to make sure that you pair up corresponding sides. Now, if this is really a similar triangle, then all three of these fractions are going to be equal to each other. So the question is, are they equal to each other? Okay. And there's several different ways to figure that out. One thing that I like to do is I like to simplify each of my fractions. So 9 over 6, I can divide the top and the bottom of that fraction by 3, and I get 3 over 2. Then I divide 12 over 8. That can be simplified to 3 over 2. And 18 over 12 can also be simplified to 3 over 2. So notice here that I have now determined that all three of these fractions are equal to 3/2, which means that those three fractions are equal. So we would say that the side lengths of these triangles are proportional. Now we've just proved that every angle, all the corresponding angles are congruent, all the corresponding sides are proportional, which means that yes, this is an example of a pair of similar triangles. So we're going to write what's called a similarity statement. So we're going to say, okay, triangle PRQ is similar to, this little squiggle, it means similar to, and then we're going to write the other triangle, ZYX. Now make sure you go in the right order. Notice that PRQ, the P and the Z are corresponding angles. Let me do this in a different color so you guys can see that a little bit better. The P and the Z are corresponding angles, so they're both going to go first in my similarity statement. Then the R and the Y are corresponding angles, so they both go second. And then Q and X are also corresponding angles.
Teachers, good afternoon. If you are not on a Zoom call, your lunch/dinner is set up in the main hall. If you can't remember specifically what you ordered, please check, because we only have exact numbers. And then Lisa wants you to sign so we know who to run food up to who may not have come down and picked it up. So come down and set up right in front of the main office.
Sorry about that. They just made an announcement over the speakers. Okay, so we've written our similarity statement. Now we just need to fill in what the scale factor is. So the scale factor, we've actually already done all the work for it. It's this 3/2 that we found in the statement of proportionality. The scale factor tells us how much bigger or smaller one shape is than the other. So 3/2 is the same as 1.5. So we would say that the triangle PRQ is 1.5 times as big as the triangle ZYX. Okay. All right, let's go ahead and do another example here. So now we're going to look at some quadrilaterals. Remember, quadrilateral means it has 4 sides and 4 angles. First, let's list out some congruent angles. So notice that this is kind of an interesting shape because I have 4 right angles. So really, all of these angles are congruent to each other because they're all 90 degrees. But we're going to go ahead and pair them up. Angle A is congruent to angle T. Angle B is congruent to angle U. Angle C is congruent to angle V. And angle D is congruent to angle W. Now we want to write our statement of proportionality. So now we need to prove that our corresponding sides are proportional to each other. So I'm going to go ahead and look at the shorter sides of my rectangle, the 9 and the 6. Those are going to pair up with each other. And then the 12 and the 10 are my other pair of corresponding sides. So I make a fraction out of both of them. And now I'm going to simplify both of the fractions. Because remember, my goal here is to figure out, are these two fractions equal to each other? If I simplify 9/6, I get 3/2. If I simplify 12/10, let me go through the steps of simplifying. We might need some extra practice with that. When you're simplifying a fraction, if you have 12/10, to simplify it, you look for what number could you divide both the top and the bottom by. So you can divide 12 and 10 by 2. So we'll divide them both by 2. And that gives us 6/5. Okay. Now we're going to look at our two simplified fractions. 3/2 and 6/5 are not equal. They're not the same fraction, which means the side lengths of these two rectangles are not proportional. So these are not similar. If they're not similar, you can't have a scale factor. So you could just write none here, because they're not similar. Okay. All right, let's look at another one. This next one is a pentagon because it has 5 angles. And we're going to go ahead and pair up our congruent angles. So remember that these little arcs in each angle tell us that the angles are congruent. So you'll notice that angle B and angle G both have just one arc, which means that angle B is congruent to angle G. Then you'll notice that angle A and angle F have 2 little arcs in them, so that means that A is congruent to F. Then let's look for where we have 3 little arcs. We have angle D, which corresponds to angle E. They both have 3 little arcs. And then finally, angle C is congruent to angle H because they have 4 little arcs in them. Also, I've got to backtrack. That is not a pentagon. That is a quadrilateral. 4 sides, 4 angles. Sorry about that. So I found that my shape has 4 congruent angles. So I've got the first piece of similarity. All the corresponding angles are congruent. Now I need to check my corresponding sides. This part can get a little messy, so I'm going to go ahead and color code my corresponding sides. So the side BA is the side that connects the angle that has 1 arc and 2 arcs. So that's going to correspond with FG. Let's see what other colors I have. We'll use purple for the side that connects the angle with 1 arcs to 4 arcs. That's going to be HG here. Okay. Let's use green. Green's going to be our longest side of both of them. And then we'll just make the other one blue. Okay. So the reason I'm color coding these is just so that we can see the corresponding side lengths. Because when you write your statement of proportionality, you have to make sure that you pair up the right sides together. So for example, when I start making my fractions, I'm going to put the red, I'll do the red sides first. That's 7/5. Okay. Now I've put the 7 on top, which means that now the top of all of my fractions needs to be from this first shape. That's going to be the top of all my fractions. Okay, my next side lengths, like my purple side lengths, that's 14/10. My blue side lengths are 21/15. And then my green side lengths are 28/20. So let me show you guys another way that you can confirm if these fractions are all equal to each other. We've done it before by simplifying each of the fractions to see if they're equal. You could also convert the fractions to a decimal. By doing 7 divided by 5, you'll get 1.4. 14 divided by 10 in your calculator, you're going to get 1.4. 21 divided by 15 in your calculator, you're going to get 1.4. 28/20 in your calculator, you're going to get 1.4. So notice how all of these fractions converted to the same decimal, 1.4. That tells us that all these fractions are equivalent. Okay? That means that all the sides are proportional. So yes. Whoops. My pen won't write the E here. But yes, these are going to be similar triangles. One second, let me see if I can get my pen to... There we go. Yes, they're similar. So let's write our statement of proportionality. So a statement of proportionality is going to be when I list out the vertices. So I could have A, B, C, D. That's my first figure, is similar to, and now I've got to make sure I match it up with corresponding vertices. So A and F are corresponding, so that one goes first. B and G are corresponding, so that goes next. C and H are corresponding, so that goes next. And then D and E are corresponding, so that goes last. So as you're writing your similarity statements, know that the order does matter. The first half of your similarity statement, you can kind of just write out however you want. The next one, though, you have to make sure you match up so that it corresponds. All right, let's finish our scale factor really fast. Remember, the scale factor is the easy part. We've already done all the work for it. Scale factor here is 1.4, or you could write it as a fraction, 7/5. Okay? It's just whatever those fractions simplify to. Now, actually, before we move on from this problem, I want to point out something. It is possible that when you wrote your statement of proportionality, you have all your fractions upside down. So you might have 5/7, 10/14, 15/21, and 20/28. That is totally fine. So let me write out what that would look like. You could have all the same fractions but flipped. Okay, so notice here in this set of black fractions, all the numerators, or the numbers on top, are from the smaller shape, and the numbers at the bottom are from the bigger shape. You can choose to do it however you want. And if you do flip it this way, your scale factor then is going to be a little bit different, because now your scale factor is going to be 5 divided by 7, which is 0.714. So if you're doing this and you're pretty confident you're doing it right, and you get a different thing than your neighbor, I would check. See if you guys just did your fractions backwards or opposite. And that's okay if you did, as long as you are consistent with it. So that was some practice in how we would prove if shapes are similar. So now let's say we already know the shapes are similar. And let's go through how we could solve or find some missing side lengths if we know shapes are similar. So in this first example, I'm going to tell you that triangle ABC is similar to triangle XYZ. So that means that the A and the X correspond with each other. The B and the Y correspond with each other. And then the C and the z correspond with each other. Okay. Now we want to find what x is. So one thing we know about similar triangles is that your angles are all going to be congruent and that corresponding sides are proportional. So let's write out a statement of proportionality here. If I look at side length AB, that's 15, that's got to be proportional to the side length over here, 9. The side that's connecting the x and the y. I put these little circles and squares so that you could see, it might be easier to see the corresponding sides. So the A and the B have a circle and the square, the x and the y have a circle and the square. So 15 over 9 has to equal x, which is the B and the C, which is the circle and the triangle. So x over 6, which has to equal 20 over 12. Okay, so because these triangles are similar, we know this has to be true. This statement has to be true. Now to solve for x, I am just going to choose 2 of the fractions. It doesn't matter which 2 you choose, just choose an x and then one of the other ones. And then I am going to solve it by cross multiplying. So remember when you cross multiply, you multiply the top of one fraction with the bottom of the other. So you get 12x is equal to 20 times 6. And basically the point of cross multiplying is it gets rid of your fractions, which gets you one step closer to solving. So 12x equals 120. Divide both sides by 12, and x is equal to 10. All right, I would recommend pausing the video here and trying number 2 on your own, and then come back and check your answer. Let's go ahead first and make sure that we know what's corresponding to what. So our A corresponds with x, and again, I'm using this similarity statement given to us in the instructions. I know that B corresponds to y, and I know that C corresponds to z. Okay, so let's go ahead and write a statement of proportionality here. AB, which is 3, is going to be proportional to side length 6. And then x, or BC, is going to be proportional to 10. And then AC, 4, is proportional to 8. Okay. And then again, you're just going to choose 2 of your fractions. You're going to cross multiply. So I get 30 is equal to 6x. Divide both sides by 6, and I get that x is equal to 5. So that's going to be the value of x in that missing triangle. Okay. Now, before we move on from number 2, I just want to point out that number 2 you could probably do without doing any sort of cross multiplying. If you start looking at this triangle, you'll notice that if you look at your corresponding sides, 3 and 6, you could figure out the scale factor really fast. 3 times 2 gives you 6. 4 times 2 gives you 8. So then what does x have to be so that when you multiply it by 2 you get 10? X has to be 5. So if you can see the relationship just by looking at the triangles, that's fine. If you can't, then do your cross multiplying. Okay. All right, let's do a more complicated example. Let's say we've got this quadrilateral. It's kind of a funky shape. We know they're similar. They tell us that right here. This is one of those things that don't trust anything similar unless it tells you to, or you've proved it to be so. So we know they're similar. So we're going to go ahead and figure out a bunch of stuff about this shape. Before we do, I am going to label my corresponding angles just so that we can easily work through this problem. So I know that F and P are corresponding. So I'm just going to, I'll underline F with purple and P with purple. And then we know that G and H are corresponding. So we'll put circles, G and Q are corresponding. So G and Q are corresponding as well. We know that H and R are corresponding. So H, R. And then, I don't know what to do for this last one, so we'll do a square. We know that J and S are corresponding. Okay, you do not have to label your vertices like this. It sometimes helps me so that I can easily see which sides are corresponding to each other. But if it doesn't help you or if it's confusing, then don't do it. What we want to do is list all the pairs of corresponding angles. all the pairs of congruent angles, which are going to be the corresponding angles. So we know that angle F is congruent to angle P. We know angle G is congruent to angle Q. We know that angle H is congruent to angle R, and we know that angle J is congruent to angle S. If you didn't label your vertices in some way, you also could have just come back to the similarity statement up here and matched up. First letters are corresponding, second letters are corresponding, third letters are corresponding, fourth letters are corresponding. All right, let's write a statement of proportionality. So here we already know that our quadrilaterals are similar, so we know the side lengths are going to be proportional. So just go ahead and start writing out our fractions. So I'm going to have 9 over 6 is equal to, and I'm going to go counterclockwise around, 18 over, over x, which is equal to z over 7, which is equal to y over 10. Okay? When you're doing this, one thing you want to make sure, and you don't want to double check it, make sure that all of the numbers or the variables on the top of your fractions are from the same figure, and all of the numbers or variables on the bottom of your fractions is from the second figure. So now I want to know, what's the scale factor? Remember, we use these fractions from the statement of proportionality to find the scale factor. So in this case, our scale factor is 9 over 6, which is probably better to write as a fraction, 3 over 2, or as a decimal, 1.5. Okay. All right, let's go ahead and find some angle measures. So what's the angle measure of F? Well, we know that F and P are corresponding and therefore congruent angles. So we would say that angle F is the same measure as angle P, which is 81 degrees. Angle H, we said, was congruent to angle R, so it will also be 45 degrees. We know angle Q and angle G are congruent, so angle Q is 144 degrees, and angle S is congruent to angle J. Both of those would be 90-degree right angles. Now we're going to find the values of our three variables, x, y, and z. So to do that, I'm going to go back to my statement of proportionality. So to find x, I'm going to take two fractions from my statement of proportionality and cross-multiply them. Maybe if I can write. So I'm going to have 9. Sorry, my pen's wigging out. So 9/6 is equal to 18 over x. Do some cross multiplying. So 6 times 18 is going to give me 108. So 108 is equal to 9x. Divide both sides by 9, and I get that x is equal to 12. Okay. Now I'm going to find the value of y. So I'm going to repeat the same process, but now, instead of using the 18 over x, I'm going to use the y over 10. I'm going to cross multiply. Get 90 is equal to 6y. 90 divided by 6 is 15. So our y is equal to 15. For my value of z, again, I'm going to repeat the same process, but now I need to use the z fraction. So 63 is equal to 6z. Divide both sides by 6. And z is equal to 10.5. Okay. If you need a refresher on cross-multiplying, you can probably just Google or YouTube cross-multiplying examples, and it'll give you some great examples. One thing to notice here that I think is important to note is that we are allowed to have decimals as your answer. So sometimes we get a decimal answer and we question whether it's right. Decimals are totally allowed, so stop questioning them. They're okay. Now let's get into some real-world examples of this. So sometimes you would do all this math and we're like, what is the point of it? Or how does this even show up in the real world? Here's a couple examples of places where similar figures and proportionality come into play. So let's say we've got an elephant that's standing next to a 6-foot tall car. So let's go ahead and draw the 6.5-foot car. Make it a little bigger. This is 6.5 feet. That's the car. And the car is casting a shadow that's 33.2 feet long. So let's make a triangle out of that. This shadow on the ground is 33.2 feet. The elephant, I'm going to draw him in red. So he's standing next to the car. So he's like right next to him. And its shadow is 51.5 feet long. So it's going to kind of overlap with the car shadow for part of it. Oh, my pen just wanted to turn off again. And that shadow is 51.5 feet. And we want to know how tall the elephant is. So I'm going to put an X over here. And the X represents the elephant's height, the height of the red triangle. And then the blue numbers are going to represent the height of the car, which is the smaller blue triangle. Okay. Now notice these two triangles are similar. We know they're similar because the way that the sun casts the shadow is going to create similar triangles. So we're going to go ahead and write a statement of proportionality. So we're going to take the height of the elephant over the length of the elephant's shadow. That should be equal to the height of the car over the length of the shadow of the car. Then I can cross multiply. So I get 33.2x is equal to whatever 6.5 times 51.5 is, 334.75. Divide both sides by 33.2, and x is equal to 10.1. And with all of these, just so you guys know, I am rounding. So this is really like 10.08283133, and I'm rounding to the nearest tenth. This is a great example. Don't be scared of decimals, right? They showed up all over this problem. Okay, so in number 2, we have a similar sort of scenario. We're going to be comparing two heights, and they're both caused by the sun at the exact same time. So the two shapes that are going to be created by this are going to be similar. So let's say we have a telephone booth that's 8 feet tall, and it casts a 4-foot long shadow. Now, most telephone booths I know are straight up, so I'm going to put a little right angle there. Then we've got the height of a nearby lawn ornament. So it's going to be smaller than a telephone booth, I would assume, right? And its shadow is 2 feet long. And I want to know, what is the height? Now this is an example of one where I would not cross multiply to solve this problem. I would just say, okay, I'm going to compare the length of the shadows. To get from 4 to 2, I had to divide by 2. So then if I'm going to compare the height of the figures, I can also just divide by 2. Which means that x is equal to 4, because 8 divided by 2 is 4. Now, if you hate what I just did, you can totally set up fractions and cross multiply. It's totally up to you.